Okay, fine. So let me introduce myself first. So this is Prasad. I have 16 years of experience. I'm working as an architect. So I teach DevOps, AWS, and .NET. Okay. So why .NET? I was a .NET developer. Later I became an architect. Okay. So yeah, I also teach Node.js and Python as well. Okay, but this institute is for dedicated to DevOps, AWS, and .NET. Fine. And yeah, so let us start the DevOps and AWS demo session. Now, whenever you are planning to learn any technology, sorry, whenever you are planning to learn any technology or process or any language, first of all, we need to know why we should learn that. Am I correct? And what is it? Fine. So why DevOps is the question. So let us try to understand why DevOps. In the process. You will also get to know what are all the tools I will be teaching as part of this particular course. Fine. Now, definitely, most of you are, I mean, based on your introduction, I got to know that most of you are working. Definitely, you would be working for a project. So, when you are working, see, normally, where do you get these projects from? From some other client, right? So, from some other organization. Usually, client directly doesn't allocate or assign a project to one particular organization. Client would be verifying n number of organizations, and based on some considerations, client would be allocating or assign a project to one particular organization. Now, my point is on what basis they do. Okay, so I would say very important point is it should be cost effective. Cost is major factor, and second one is whoever delivers it fastest delivery, and at the same time they look for quality and high availability. Always your application should be up and running, not even a single minute it should be down when you are maintaining the project. These are all the factors. Each and every organization wish to achieve these four, but for some reason it is not happening for all, right? So let us try to understand organization structure first. So I'm just dividing the organization into two teams. One is development team and second one is operational team. Who comes under development team? Developers, testers, project managers, whoever is responsible for delivering the project, they come under development team. Who comes under operational team? So these guys are actually admins. So these guys are admins. So they own the environments like test, UAT, and production environments. Okay. So now I will come to the what is an environment, what is development, deployment, all the terms. I'll definitely explain before I start the main part. So, and now my point here is ultimate aim is to achieve these four. Day to day life, these two team members would be facing some problems. Correct? If you can able to identify the problems faced by these two teams and provide solutions to those issues, then we could achieve this. Correct? Now let us try to understand the problems faced by development team members and operational team members. Okay, fine, then we will come to the solutions of it. Fine. Now before I go to that, we need to understand few technical terms I will be keep using in this demo. One is development and deployment. Development meaning you have some requirements. For that requirements, you are writing some code using some language or some technology and making it work in the developer system. That we call it as development. Deployment meaning, yes, it is running successfully in the developer system, but I wish to run it in some other system and I should make this particular application available to others as well. Then what do you do is the question. Then we need to run it in some other system or set of systems. We call it as servers. Correct? Why in multiple systems? Because if any one system, if you are deploying in one system, if that system goes down, then your application goes down. So that's the reason you usually deploy it in multiple systems. Okay, then that multiple servers, we call it as environment. It can be one system or multiple servers. Okay, now directly just copying the files from the developer system to that particular system or server is not sufficient. Okay, let's say I have 100 Java files or .NET files. You can't directly just copy that into other system and make it work. You can't make it work. Directly doesn't work. There has to be something, okay, some other software for that. You need to configure, you need to install some softwares, you need to configure something. You may need to create some users, then copy the files from this system to other system and making it work that system is actually called deployment. Okay, so running the application in developer system is actually called development. Running the application in some other system or set of systems is actually called deployment. Okay, fine. Now I was talking about the environment. So you will have environments like dev environment, test environment, UAT environment, and production environments. So, and there will be like staging and pre-prod also sometimes people uses it. Now, what is it and why do we need to understand all this? So, development environment meaning developers usually deploys the application into the dev environment, and as I mentioned, development environment meaning set of servers. Okay, now why are we calling it as dev environment? Developers only test the application in the dev environment, no one else. Okay, then test environment. Testers will be testing the application in the test environment. Then UAT environment, user acceptance test. So client would be validating the application in the UAT environment. If everything goes fine in the UAT, client says yes, now you can deploy into the production. Okay, product actual users will be using in the production environment. Fine. So these are all the environments. Now, let us try to understand the problems faced by development team members and operational team members. When you say development team members, definitely developers would be working under that particular development team. Now, developers usually write some code. That code, we call it as source code. It irrespective of the technology. It can be Java, it can be .NET, it can be anything, doesn't matter. But there will be some files, project files. Okay, that project files, we call it as source code. Now, where do you keep that source code? Initially in developer system only, but if you are storing in only in developer system, the problem would be if that system get crashed, you will be losing the code. And the second part is at some point you need to integrate the code, meaning there will be multiple developers in a project, you need to integrate the code. So manually, I don't want to disturb each person like give me your code, give me your code. So that is the reason in the common place, you need to keep that particular code. So that with the help of version control system. So let's say I am actually storing the code in the Git. Git is a version control system. There are n number of version control systems, but we will be learning the Git. Now in the Git, we are storing the code. Now we have the code, project code in the Git. Now, as I told you, deployment. Okay, now deploying the application into the dev environment is the responsibility of the developers. Now, they will be deploying the code once in a day. Once in a day. Why not many times a day? Because their core job is to develop it, not to deploy it. Correct? So that is the reason before they leave office in the evening around 5:30 or 6 o'clock, so they will be deploying the code into the dev environment. Okay, I'm not talking about other environments, into the dev environment. Now, while deploying the code into the dev environment, if any issue comes, everyone in the team should sit and fix that particular issue. Why everyone in the team? Because morning to evening, multiple developers worked on that particular code and they pushed it. So we don't know who has introduced that particular issue. So we need to identify that. That's the reason everyone in the team should sit and fix that particular issue, and they are supposed to fix that particular issue on the same day. Why same day? Why not next day is the question. So the reason is we work on agile methodology. Now the question is, what is agile? Let us first try to understand what is agile, then again we'll come back to this one. Now, as soon as you get the requirements from the client, directly you don't start coding it. Okay, so you need to follow some process. If you directly start coding it, what will happen? The problem would be it might not be successful. Correct? So that's the reason there is a process. That process we call it as software development life cycle. SDLC we call it as. Definitely many of you would have heard about it, but let me just briefly explain about it. Now in the SDLC you will have phases called requirement gathering, analyzing the requirements, design, development, testing and maintenance. Each phase is self-explanatory, but just explain it. So now requirement gathering, you gather the requirements. Analysis meaning you analyze the requirements. Design meaning you design the project, meaning it's not the UI design. I'm talking about architecture of the project. Okay, who does that? Architect will be doing it. Now you will get HLDs and LLDs like high level design and low level designs. Using that, developers would be developing the project in the development phase. After that, testers would be testing the application, then the maintenance. Now these phases can be implemented by using multiple methodologies, and two of the popular methodologies are waterfall model and agile methodology. Now, what exactly waterfall model says? You completely finish one phase of the SDLC, then only you move to the next phase of the SDLC. Okay, so you gather all the requirements, okay, then you analyze all requirements, then you design, then you develop, test like this. So one phase fall into the next phase. Okay, now according to this, let's say the project duration is 12 months and you have 100 requirements. Now when do you get into the testing phase, or when do you complete the testing phase? In the end, right? Like around 10th month end or 11th month, am I correct? So till that time you will not be in a position to go to the client and ask for a feedback, correct? Because you don't feel confident, correct? So that's the reason. Now let's say that at that time you go to the client and ask for a feedback. Now client says, this is not what I have expected. I need these changes. Okay. Now, if those changes are small, you can accommodate it. But if those changes are big, then you will not be in a position to accommodate those changes. Okay. The reason is you are at the end of the project and you might have spent all the money, whatever you got it from the client. So these are all the problems. Okay. Sometimes clients think that whatever they are actually asking for are small only, we are making it as big. Okay, but I'll just give you one example. Let's say there is one car manufacturing unit. Now, they have manufactured around 10,000 cars. Now, they are intended to be sold it in India. Okay, now, because of some reason, some legal issues or something, now they have decided that they can't sell it in India. They should be selling it in UAE market. Now, in UAE, you know that in India, actually, the steering comes on the right hand side. In UAE, the left hand side. Now there is an issue, correct? Now someone from the sales department suggesting, saying that, why can't you pull this from right hand side and fix it in the left hand side? Is it so easy? No. The reason for that is, since it exists in right hand side, accordingly the other parts of the vehicle like engine and other parts of the vehicle you aligned in that manner, correct? If you are changing that, definitely even other parts of the vehicle needs to be changed, correct? So that is a problem. They don't understand that, correct? The same way, even in the software applications also, you may need to change the entire architecture. No, okay, or major part of it. So that becomes a problem, correct? So that is the reason most of the cases are only 30% success rate is there in the waterfall model. Okay, so now what is the solution? The solution is Agile. Now in Agile, what exactly we do? In Agile, you don't take all the requirements at a time like 100 or whatever. You take few like 10, 15, 5 or whatever, and you execute these requirements in short duration. Okay, so short span of time. That can be 2 weeks or 3 weeks or 4 weeks. This duration, we call it as sprint. Okay, now in this particular duration, you follow all SDLC phases only for these requirements, not for all the requirements. Now, at the end of that particular period, like 2 weeks, 3 weeks, or 4 weeks, you should get a workable product so that you can take a feedback from the client. So then you go to the client after end of that particular 2 weeks, 3 weeks, or 4 weeks and ask for a feedback. If client says, I need some changes, even though those changes are major, you can definitely accommodate those. The reason is you are not taking the feedback in end of the project. You are taking the project in the like every 2 weeks. Very often you are taking. Now let's say you are taking 10. In the next sprint, what do? 10 more you take it. Then at next sprint, 10 more you take it. Like that you will be. So if any requirement is not accepted by the client, those let's say out of 10, 8 are accepted, 2 are not accepted. The 2 you will do it in the next sprint. Okay, so it's like writing your semester exams instead of directly writing the final exams. Whatever the topics you cover in first semester will not be repeated in the next semester. It's like that. Okay, so since you are taking the feedback very often, you become confident, and there is a possibility of making the project successful. So that's the reason most of the projects are actually going on agile nowadays. Okay, now let us come back to the issue faced by development team members. Okay, now I was actually talking about 2, 3 or 4 weeks, right? Most of the cases we work on 2 week sprint only, not on 3 or 4, because 3 or 4 are almost a month. We shouldn't be waiting that much time. So that's the reason. Okay, so when you say 2 weeks, it's 14 days. Weekends we don't work, that's why we are here, correct? And then it becomes 10 days. Then 1 day is required to take a feedback from the client, then it becomes 9 days. 1 day is required for integration test, even though people says like we don't need that much time, but still people takes that much time when you check the entire sprint actually. So then it becomes 8. Okay, then half a day is required for planning the sprint. What are all the requirements we should be taking for that? Okay, then minimum 8 days I would say, or 7.5 days only you will get it. Okay, maximum 8 days or 7.5 days you get it. Within this period you need to execute the requirements which you have taken that sprint. So we have very less time. Now let's come back to this issue, the issue faced by development team members when they are trying to deploy the application in the evening. If any issue comes, they are supposed to fix it on the same day. If they come on next day and try to fix that issue, until that issue fixed, other developers would be idle, because every day in the morning you should take the latest and work on it, right? So then it becomes a problem because there is an issue. Now again in the morning you should be fixing it, then you are wasting the time over there. So that's the reason they are supposed to fix it on the same day. See, let's say they were there in the office till 9:30 or 10 o'clock. Now the next day they'll come late to office. If not, what, at least 2, 3, I mean like not 2, 3 hours, at least 1 hour they'll come late to office. There are 6 developers. If each person is coming like 1 hour late, then it becomes 6 hours. Then we are losing 80% of one man day effort. We work 8 hours per day. Correct? Now, if this is happening one day, we can adjust. If this is keeps happening, then the problem would be, what will happen? You will not be in a position to deliver the project on that sprint. Forget about fastest delivery, not even delivery. Correct? So that is a problem faced by development team members. Okay. Now we'll come to the solutions. Okay. Now what is the problem faced by operational team members? Now I said these guys are admins, they own the environments like test, UAT and production environments, right? Now even though they are owning the environments, there are some configurations related to the application. Developer would be knowing it. So that's the reason they both sit together and they will be writing the instructions saying like this is how it should get deployed into the other environments. Using that instructions, operational team members would be deploying it. Now, while deploying, if any issue comes, operational team member tries to approach development team member. Now, development team member says, I am into Agile. I am working on my own task on the development. Whenever I get time, I'll assist you. If that whenever comes quickly, not an issue. Otherwise, this is getting delayed. Okay, client would be watching. This is not getting deployed. But the point here is no one is trying to waste the time. But still, it is getting delayed. Correct? So that is a problem faced by operational team members. Again, it comes down to the fastest delivery only. Correct? So those two are the problems faced by development team members and operational team members. Now we need to find a solution for those two issues. Now the solution is, if the development team member and the operational team members communicate and collaborate with the help of automation tools. Then we get a solution. That is DevOps. Okay, so you would have seen when you say DevOps logo also, it would be Dev and Ops, right? Yeah, correct. So that is the communication and collaboration between development team members and operational team members is automation. See, communication is already happening, collaboration is already happening. But what is not happening is automation. Correct? Now we need to use that to find a solution to this. Now let us focus on first one. So we are trying to deploy the application into the dev environment in the evening before they leave office, but that too once in a day. Correct? Don't do that. Each time developer push the code, you try to deploy the application continuously. Meaning, let's say there are 6 developers. I am pushing the code at 11 a.m. Till that time, everything is working fine. Now I just pushed at 11 a.m. If any one of the developer tries to take a build at that time, now if any issue comes while taking a build, okay, now build is more than compilation. It's not only compilation, okay. Now while taking the build, if any issue comes, if that particular developer send and informs to all the developers saying that there is an issue in the build, then everyone knows at that time who pushed it. I pushed it, so I am the responsible person to fix that issue. Others can focus on their own tasks. Correct, right? So that is a solution. But there is a problem in this as well. What is that problem? The problem is there are 6 developers. Let's say each guy is pushing the code minimum 3 times a day. Now the problem would be if any one of the developer is trying to take a build 6 into 3 18 times, all 18 times. So if that developer is trying to take a build, then that person will be working on only on the deployment, not on the development. Correct? Now either to develop or deploy, you need to hire one more person. Then again cost would be increased. Correct? We are not supposed to do that. So that is the reason what we should be doing is we should automate that process. Correct? So how do you automate that process is the question. To automate that process, we have CI/CD tools. What is CI? I'll come to that. But there is a tool called Jenkins. Okay. Now, is this the only tool available? No, there are multiple, but this is a widely used tool. That's the reason we are trying to learn this. Okay. Now, in this particular Jenkins, what do? You create the jobs. Okay. What do you mean by job? Jobs usually runs by itself. You don't need to initiate it. Okay. So automatically it runs. Okay. When exactly it runs? Each time developer push the code, this job would be triggered and this would be running. Okay, now in that job you need to configure such a way that, see, we already have the code in the Git. Correct? Now you take the code into the system wherever Jenkins is running. Okay, so that is first thing. You take the code into the system wherever Jenkins is running. Now after that you need to use the related build management tools. Now don't think that DevOps is related to or tied with only Java, Node.js or Python or something. Okay, it is a process. Okay, it is a process. Okay, it is not tied with any language. Okay, fine. Now I am taking an example of Java. For Java, people uses either Ant or Maven as a build management tools. Okay, now why do we need this? See, in the background, you are trying to do everything. It's not like manual process. Now, there has to be one tool to do the job for you. Now, these tools will do the job for you. Now, using these particular tools, you can first compile the code. What do you mean by compilation? Converting your source code to mission understandable language, correct? So that's a compilation. In that process, if any issue comes, okay, then you need to report it. Okay, now first you compile it, then you unit test the code. Unit test the code. Unit testing meaning it's not a feature testing, it is not a functionality test, it is a function test. Developers usually write some functions in their code. Okay, now to test that particular function, they will be writing some other functions. For example, let's say there is a function called add a comma b. Now they will be creating one more function. In that function, they will be calling like add 2 comma 3. They'll expect 5 as a return value. If they get 5, then that is successful, otherwise it is not successful. Okay, so like that unit testing will be there. You can test that unit testing also over here. Okay, so after that there will be some automation test cases. People will be using something called Selenium and all. Using that, they will write some automation test cases. Even that can be configured over here. And after that, there is a tool called SonarQube. SonarQube. Okay, so this will actually verifies like unit test coverage. Okay, and there will be some rules in the SonarQube actually. Okay, to check the code quality and all, they will be using this rules. Using that rules, it identifies, like for example, there can be different levels of experienced developers. Okay, and there is something called performance oriented code. Each developer will not be writing like whatever the code you are expecting, correct? Now that is the reason, before pushing the code, someone needs to someone needs to review that particular code, and reviewing line by line is difficult for anyone. Okay, so that is the reason, using this tool you could automate that process also. Okay, there will be some rules in this particular tool. Using that rules, it will review the code, and also whether unit test coverage is 100% or not, all that it will be verifying it. Okay, even that you could configure in this process. So after that, you would be generating the archive files. I'm just taking an example of Java. So for Java, we use jar, var, or ar. These are all archive files. It depends on the, there are different types of applications in Java. So accordingly, you will get these archive files. Okay, now what do you mean by archive files? I have 100 Java files. I have compiled it. So after that, I got 100 class files. Okay, now I wish to share these files to someone else, to the some other system. You don't share one file at a time, right? You need to bundle it and share it, right? So that bundling process is jar, var, or ar. Okay, so till this process, whatever you do it, I'm not trying to deploy it, I am just trying to generate the archive files. Okay, now till this, whatever the process you do it, this we call it as continuous integration. Continuous integration. Why am I calling it as continuous integration? At any given point of time, your code is deployable code, because you are compiling, correct, and you are unit testing, sonar cube, everything is happening. At the end, you are getting the jar files, var files, or ar. And when it is happening, each time developer push the code, this process is happening, correct? And if any issue comes while in this process, you automatically send a notification to the development team members. Notification, it can be a email, correct, it can be a email, or it can be a Slack message, it can be anything, doesn't matter. Okay, so that we call it as continuous integration. Using this process, the first issue is resolved. You're not deploying it. If you wish to deploy, you can even deploy it. Okay, the first issue is resolved. Now you are not taking a build manually in the evening before they leave office. Each time developer push the code, this is automatically getting built, correct, right? So the first issue is resolved using this process. Now in this process, we actually learn git. Okay, I'll explain one more, and let us verify this as well. So what is the issue faced by operational team members? Now they are trying to deploy the application into the test UAT and production environments. So they are facing some issues. Even for that, you could actually create one more job. It's not like only one job you can have it in the Jenkins. You can have multiple jobs. Okay, so there will be something called Tomcat. I am talking about web applications. For web applications, you generate the var files. That var files will be deployed into the Tomcat by using one more job. That process we call it as continuous delivery or deployment, CD. Okay, continuous delivery or deployment. Okay, using this particular process, even this issue is resolved. Okay, because we are automating that process also. If any issue comes, only in the first round you will encounter those issues. Afterwards, anyway, you'll be fixing it, then you don't face any problems. Okay, so now both the issues are resolved using this. Now in this process, we will be learning Git, Linux shell scripting, Linux shell scripting, and Java Node.js build and release part, then Maven, SonarCube, Tomcat, Jenkins. Okay. Now there are other tools also. I'll come to that. And before I get into that, any issues, any questions, anyone? All these, there are more, few more as well. Okay, I'll come to that. Okay, so I mean, any questions till now? Is this clear? Clear? So it was related to the master delivery. Yeah. So DevOps can be used for the quality. Yeah, I'll come to the high availability next.
What
Okay.
about Dockers and the Kubernetes?
Yeah, I'm coming to that. I'm coming to that. So till this particular point, do you have any questions?
No.
Okay, fine then. Now, there are other tools also in the DevOps. Before I get into that particular tools, I wish to explain the cloud platform. Okay, now we are talking about this entire process, right? Meaning the deployment, correct? The development, whatever. Okay, so now where do you do this? You need to have infrastructure, right? Correct? So that can be your on-premise servers, meaning your company owns servers, or you can have somewhere in the cloud, correct? And there are n number of clouds. You have AWS, Amazon Web Services, you have Azure, you have Bluemix, you have CenturyLink. There are n number, Alibaba, so many. But we will be learning the AWS. The reason for that is 75% of the market is occupied by AWS. So that is the reason. Okay, there are many known reasons. So that we will be learning in the actual sessions actually. But we will be learning AWS. In the AWS, there are two packages. One is partial and second one is full AWS. In the full AWS, all the services which comes under solution architect certification, I'll be teaching. I'll anyway open the services. But in the partial AWS, I teach EC2, S3, auto scaling, load balancing, VPC, IAM. These are all the 6 AWS services which would be part of partial AWS. Now EC2 is actually to create the virtual machines in the AWS. Okay, then S3 is for storage, unlimited storage. Fine. Then auto scaling load balancing is actually for high availability. For high availability and the load balancing. Okay, so that is for your EC2 instances. VPC is actually for networking. Okay, now to create your own network in cloud, we use VPC in AWS. Fine. IAM is to secure all your AWS services. We actually use IAM. That is for security. Okay. Now, apart from that, like I mentioned, so in AWS, in the full AWS, these are all the topics I will be covering it in full AWS. I'll just open the document. We'll just the ones which are marked in red are would be covered in the full AWS. I'm not saying these 6 will not be covered. Everything, correct? So the ones which are in black color are partial AWS ones, but in full AWS, all these would be covered, like databases, okay, storages, okay, there are multiple storages actually, EFS, okay, so all that storages, FS6, all that will be covered. Then cloud formation, elastic beanstalk, SNS, SQS, SES, Lambda for serverless, API gateway for your Lambdas, okay, the triggers, then Cognito, CloudWatch, CloudTrail, CloudFront, ECS, CCR, all this would be covered as part of the full AWS. Okay, all the services which comes under solution architect certification. Fine. Associate. Then, apart from that, in the DevOps I'm talking about now. So that is about cloud. Now in the DevOps, there will be something called Docker. So what is this? Docker, using Docker you can create the containers. What is a container? In using containers, you can develop, deploy and ship your applications. You can develop, deploy and ship your applications. Now, there is a virtual machine concept, right? I said EC2 is a virtual machine. You can also create virtual machines in your own system also by installing a software called VMware. Okay, so physically trying to have a physical server, you can create a virtual machines also. Now when you are creating a virtual machine, in a virtual machine, for each virtual machine you need an extra operating system. When you say extra operating system, you need extra resources like RAM and other memory, other resources you need more in the virtual machines. But whereas in the Docker, you don't need extra operating system. Okay, so the reason is it shares your operating system. Okay, so since it is sharing your operating system, you don't need extra resources. Correct? So that is the reason Docker is more popular, and there are other advantages also by using Docker. Okay, now let's say for example, I have only two environments. One is prod and second one is for dev, UAT and test or whatever. Okay, then what you can do is you can have one container for dev, one container for UAT, one container for test, like that you can have it. Okay, so there are other advantages also. That is the reason Docker is more popular, and for microservices, Docker is extensively used. Okay, so now that we will be learning as part of this particular session. So how to create, like what is a container, what is the image, okay, then what is Docker networking, like Docker use creating a Docker image manually, automation and Docker Compose, all that you will be running as part of this particular course. Then you learn something called Kubernetes. What is this? Container orchestration mechanism. In a cluster, how do you manage your containers? In a cluster meaning set of servers. In the set of servers, I wish to deploy my containers. So how do you do it? Okay, for that we will be learning the Kubernetes. Then we will learn something called Ansible. What is Ansible? Let's say I have one server. In that particular server, I wish to install Java, install Maven, and create one user and assign that user to the group and copy some files. Manually, yes, if it is a one system, you can do it, not an issue. If the same process you wish to repeat in 20 servers, then what do you do is the question, correct? It takes some time, and there is a possibility of making mistakes also. And once you make the mistake, you need to get to know where exactly the problem is, and you need to find a solution also. Correct? This takes time. So that is the reason, to avoid it, we can use this particular tool. We call it as here we write infrastructure as a code. Here we will be learning something called YML script. Okay, using that particular script, you could actually configure the servers automatically. Okay, so that for that we use Ansible, and we also learn something called Nagios. What is Nagios? Monitoring. What do you mean by monitor? Let's say you are deploying your application in 10 servers. Someone needs to be keep on monitoring whether those servers or services under that particular server is working as expected or not. Correct? So who does that? Manually, even though you are hiring one person, each and every minute they can't verify it. Okay, they can't keep pinging it. So that's the reason we use this particular tool to monitor the servers. If something goes wrong, it notifies you. Or there will be a web application of Nagios at any given point of time. If you wish to get to know the status of each server and service, you will get to know. Okay, for that, we will be learning the Nagios. So these are all the tools which would be part of the DevOps. Okay, and like I mentioned, there will be two packages: DevOps with partial AWS and DevOps with full AWS. And the DevOps with partial AWS is 3.5 months course, and 60 hours is the duration. Okay, then weekdays 1 hour per day. Weekdays 1 hour per day. Most probably it would be like 8 to 9 or 7 to 8. But 7 to 10, 7 to 9 you should be free. 7 to 9 in the morning. Okay, then DevOps with full AWS is actually 100 hours course. Then 1.5 month you need to attend 2 hours per day. 2 months you need to attend 1 hour per day. Okay, and all the use cases which I will be teaching as part of this particular course would be practical use cases. Okay, all my experience will be used to teach this, and you are learning this particular course to get a desired job. Okay, until you get a job, you can keep on attending the batches. I don't have any problem. Okay, so it's not like once you complete this particular course again, it's not like you shouldn't be attending. As many times you need it, you can attend the course, not a problem at all. Okay, and I will be keep sharing the daily videos with you. You can practice by using those videos, and even while teaching, wherever you have any questions, you must stop and ask me the questions. Okay, you are here to learn, so there is nothing called you are stopping the process or something. At any given point of time, if you have any questions, you can definitely ask me. You need to feel like one on one, but even though there are multiple people, you should be feeling like one on one, and you should be asking the questions. Okay, so that is how it is. Okay, now I'm just stopping the recording, then I'll take all the questions.